Hello, welcome to another segment geospatial tutorial. In this video, I'm going to show you how to segment time series remote sensing images and also videos using segment geospatial. So the Meta released the segment anything model 2 in late July, so it's about a month and a half right now. And I have been thinking about how to implement this one. So finally, I finished the implementation. So now you can easily use same tool to do segmentation on remote sensing imagery time series and also videos. And it's very exciting. So this is what I'm going to show you today. So first, if you're interested in looking at more details about the segment anything model 2, you're welcome to look at the um, GitHub repository and also the paper. They also reduced the dataset. And so we're going to adapt this one to do geospatial data segmentation. If you go to the segmentation SamGeo website, then on the left side here, examples. Also, you can take a look at the API reference. So this is right now under the SamGeo2 module. And I've added a lot of functions and capabilities. And so this is what this video is about. It's going to show you how to utilize some of those. In terms of the node examples, you can there are 3 examples right now. So you can use the same tool, automatic mode, to do automatic segmentation. You can also use the predictor. So that means you can use point, mounting boxes, and mask to do segmentation. In today's video, I'm just going to go through this one. I might create another 2 videos later, but this is the most exciting one. So I want to cover this one first, is to do time series image segmentation. And so for to try it out, I recommend you using Google Collab. So just right click here, open this one in Google Collab. You will need to activate the GPU. So go to the runtime and then check this one, change runtime type. So from here, change to GPU. Otherwise, it's going to be very slow because this is using deep learning. So you do need the GPU. And after that, you can just uncomment this one. Then you can just click this one to run, and then you can go steps by step. You should be able to run this without any problem. The only thing might be the last one. I haven't tested this one. I added this new portion here, and it might exceed the GPU memory. But for the previous section, you should be able to run. And I'm going to use this one to run this on my local computer because I already installed it, and I don't need to reinstall again. I'm running this one on a remote desktop, so it's a little bit laggy, but bear with me. It's better that I run it locally. So I'm going to show you how we can do that to do segmentation using the SamGeo tool. So we're going to use leaf map to do some visualization, and we're also going to use the SamGeo tool. Compared to the past, we're using the from SamGeo import SamGeo, just the SamGeo class. So this is the second generation, and then we're going to use SamGeo tool. So what you need to do is just simply import the library and then just run it. So specifically for this example, we're going to use the Landsat time series images from the one I put on the GitHub website. And you can download this one. And after that, you can, if you want, you can open this one on a local computer. So this is what it looks like. It has the Landsat time series from 1984 all the way to 2013. So we have 30 time series images. And if you want, you can use a leaf map or you can use QGIS. So let me show you here. These are all time series images. So you should be able to open it using any desktop GIS. So I'm going to open this one. And so let me open maybe the Google satellite imagery base map. And then you can just drag and drop this one to the map. So drag this one. Again, it's a little bit laggy here. Bear with me. And zoom to the data layer. So clearly you can see this is the imagery. So you overlay nicely on the base map. And so the coordinate system is EPSG 3857. So you can see here. And if you want, you can open, you can double click to check the coordinate information. So this is GeoTIFF and AB integer. So for now, it's only supporting AB integer. So make sure that for the time series image segmentation, you want to clip them to the same extent. So it's all the same size, same width and height. And so once you have that, you can just initialize the segment anything model. So we're going to use SamGeo2 here. you can take a look at this model. Facebook has 4 models. So we're going to use the large one, but if the GPU is, you have a small GPU, you might want to use a small one. So you can go to here, the segment NEC model, you can take a look at the model. So there are 4, tiny, small, base plus, and the large. We're going to use the large one. And it says 24 gig megabyte, but actually it's much larger. So when you can, same Geo2 will automatically download everything. So you just need to initialize the model. If it has not been downloaded, it's going to take maybe a couple minutes for you to download. So it's going to download the model directly from Hugging Face. And so we also need to set the video mode to true. Otherwise, it's going to use the automatic segmentation. That one is just for imagery. So after we initialize the model, then you can just use this one, set video. But although it's called set video, but you can also point to a directory where you contain the time series images. So in this case, we are pointing the model to looking into these images. So these are all the GeoTIFF remote sensing time series images. So we have 30 images and it's just going to load. So let me run this one here. It's going to convert the GeoTIFF to JPEG under the hood. And then it's going to load all the JPEG into the model so that we can do the segmentation. Again, the segment NEC model doesn't have capability to handle geospatial data directly. So the input is actually just a JPEG. So we need to do the conversion first. And after that, this is where you need to specify the input because we're going to segment something from the imagery. So you need to provide the label. And one thing you can do is to use the predictor.show images. Here we already load 30 images. So you can see from here, you can show all the images all at once. So let me run this one just quickly to show you. And I need to run again here. The shortcut doesn't work. So the show images, you're going to show all the images that have loaded into the model. So in this case, we have 30 images. And take a look at this one. So the first one is 1984. If it's too small, you can drag out a little bit from here. And then you can use the slider to slide through all the images. Right. So from 1984 all the way to 2013. So let me start the first one. Assume that, okay, we want to segment this river, this meandering river from this imagery. So what you can do here is to select basically some training points. So you can zoom in a little bit, use this one, and then you can place some sample points. So what you need to do is just to select, get the pixel X and Y coordinates. So you can click your mouse on the map, on the imagery. At the top here, it's going to show you the X and Y. So basically it's the column number and also the row number, right? So you can, for example, if I select this first one, 1297 and then 899, you can scroll down to the next one here. So this is basically where you specify the prompts. So the point is basically the row X and Y. So in this case, you can basically specify, for example, 1297, 899, and then we, okay, sorry, here, right? Sorry, it's a little bit laggy. Let me do it again here. Right, so what you need to do is just replace this one with whatever X and Y. So for example, this is the first one, and then I can select the second one. So this one is 1580, 929. So you can basically just replace whatever in here, and I can select another point, 4079, and then 1000. Again, you can add as many as you want, but same Geo2 is very powerful. So you only need a couple points, 1 or 2, 3 points, and that's enough. And also the label here, 111. So 1 means is the object you want to extract. If there's a point, so for example, if it happen to extract something that you don't want, you can add, for example, for this point, you don't want. So you can add this one, 50, 40, and then 866, and another point here, and then from the label, comma, 0. So that means it's going to be excluded. Basically, it's just the background. So after you have clicked all the training points, then you can just use this one, predictor.show prompts. So the prompt is the one that we already specified above here, right? So this is the one that we already created. We have clicked 3 sample points. It's all what we need. And also you need to specify the frame index because here we all click the training points from the first imagery. But if you slide to some other images, for example, you can slide to maybe index. So this one here, index 1, 2, 3, 4, right? You can have the training points on some other images. So it doesn't have to be the first one. After you have clicked all the training points in here, so the one is basically is a unique ID for the object. So if you want to create multiple objects, you can have 2, 3. So basically just a dictionary, and then you do the same thing, the same format, right? 2, and then square bracket, curly brackets, point, label, and then frame index. After that, you should be able to have this one. So I'm going to run this one right now. So you see the sort of prompts, right? So I click this 3 points, then it's the first frame, index 0. It's going to show you this one, and that's all you need. So 3 points, and then with all the time series images, now you can start running the segmentation. So again, this is just the thumbnail here. In addition, in addition to just X, Y, the absolute row and column number, you can also use basically the longitude and latitude. So X and Y. So X is longitude, Y is latitude. So you can see here, it's pretty much the same as the previous one, except right now we're using latitude and longitude. But the difference is that if it is latitude and longitude, you will need to specify the point coordinates. So under the hood is going to convert this one to X and Y. So basically row and column number. And it's up to you. So you can, for example, you can open QGIS, or you can also use leaf map to collect the training points. So here I can maybe do it this way. I can show you, right? I can click this one. You can get the coordinates from here at the bottom here. And then you just remember this one. Then you replace that on here. So if you want, you can also use leaf map. So let me show you here. I can create a map equal to leaf map dot map, and then oops, I think it's some of the, sorry, it's, I'm using the remote desktop, so the parentheses doesn't work. So let me, annoying, oops. Anyway, I'm gonna skip this one because I need the GPU, so it's right now it's a little bit laggy. But anyway, you can specify any point using latitude and longitude, and after that, just show the prompt, specify the coordinates. So this is basically latitude or longitude is EPSG 4326, and if you show the prompt again, you'll be the same. So these prompts are the same as the previous one using the XY, and that's all you need. So the next step is just to predict the video. And we're going, because we already created a model and we already load the images, so just run this one. So you see here it takes I think 16 seconds. So let me run this one just to show you, and it's going to propagate all the videos from the first frame and then to the last one, and pretty quick, like here. Okay, it's done. Okay. Oh, it's still running. So 83. Yeah, I can also show you the, for example, the GPU usage. So this is pretty intensive. So MV top, I'm on Linux, so I can use this one to check the GPU usage. So right now it's 26 because it's already done. And next step. So after that, we can save the result. So the result can save in 2 different formats. You can call this one called save video segments, and you can specify the output directory. So look at this one. So the output directory, I save it to the segment. Okay, so this one is the geospatial data. So it's the same GeoTIFF. Whatever you have is the corresponding output. So this is 1984, for example, is the segmentation result. So again, I can open this one. I can drag this one here just to show you what it looks like. Right. So right now, this is the segmentation result from the 1984 imagery. And take a look. You can also drag any other images. So right, so from here, I can drag the one from 2010. It's going to be different. So look at this, right? Because the river changed very dramatically. And so let's run this one just to show you what it looks like. So I'm going to save the video. And it's here. Okay, so save video segment. And so we have 30 segments. It's pretty quick. So this one is just a binary imagery, grayscale, but it's geospatial data. And but if you want to, for example, overlay, just look at this imagery here, overlay the segmentation result on top of the set imagery and generate the video, then you can use this one called save video segment blended. So basically going to blend the segmented result on top of the imagery, and you can set a frame rate. So frame rate, for example, how many frames per second. And in the meantime, you can also save a video. So let's run this one. And this one will take a little bit longer. So you see here, it's basically generating all the images, and then at the end it's going to combine them all together. So this is what you're going to see from the output folder here. I think it's the blended, and so this is just going to generate PNG images, and then you can just navigate through. So take a look, right? pretty nice. And after that, it's going to generate a video. So the video is going to segment, for example, here, this one. This is the result. So I ran it half an hour ago, and now I can show you the video of what it looks like. And so all we need is just 3 points. See how powerful it is. It can generate the result for all the following frames. So we only provide the sample points for the first frame, and then you do that for all the remaining frames. Really cool. Again, if you're running it on Collab, you might need to also be patient, because this is very computational intensive process. So it's going to take you a minute or two to generate the result, but it's pretty cool. So this is the first example that we handle geospatial data, remote sensing time series images. It can be anything, so it doesn't have to be river. It can be building, it can be volcano, it can be cars, drone imagery, whatever you like, right? So you just point your image video source to the directory, and then just a couple lines code, then you can do the segmentation. So the second example here, I'm going to show the segmentation using car video. So let me show you what it looks like. So let me open this one. So this is the input video. It's just an MP4, and it's just cars driving on the on the road, and we can detect whatever car, for example, just do kind of like object checking. So similarly, we're going to initialize the model. So you're going to create a model again. Again, you need to set the video to true. Then I'm going to pointing to this video file. So this is the one that on GitHub, and what you need to do. So basically, the set video, you can pointing to a directory containing all the images, or you can pointing to just a MP4 of the real video file. So this one, we're doing the real video, and I'm going to run it. So I'm going to show you, okay, it's going to download the video, and this is 25 frames per second in a total of 177 frames. And so after the video is being downloaded, it's actually splitting the video, converting the video into images, and save in a temporary directory in here. It's JPEG, and then you can load the JPEG into the model. And similarly, we can run this one to show all the images. Again, you need to collect the training sample points, right? So this is the first frame, and assume that, okay, we're going to detect, check these two cars. So what you need to do, just place your mouse somewhere, for example, on this black car, and then click and take a look. So this is the XY, and similar to what we did earlier, now we can just provide this one, right? So the point, it's like 335, 212, or 203. It's a slight difference, but it doesn't matter. So this is the first object, and nice thing about the segment anything model tool is that it can do multi-object detection, so not just one. So this is, for example, unique ID. So this is the unique ID, is basically the output value for this object when we finish the detection. And we can add another one. For example, I also want to detect this white car. I click another one here. Press here. So this one is 418, 204. So similar to here. 420, 201. Similar. And the label one, right? So this is the label basically is just the foreground. If the 0 is background, so you can add more points. But if this background, you can also comma 0. And so the frame index. So this is the first frame. Again, there are multiple frames. So if at some point in the later, if the frame, for example, the object basically disappear, then you can actually add more points. So you can add multiple frames. So for example here, later on, if this object is not detected, then you can, for example, add another one, and then you get the point, and then you can pass into here, and you can add to the prompts. So after it's done, then we can just execute this prompt in here, right? Run it, and then we can use the show prompts. Again, this is the 2 points that we just collected, right? So just 2 points in here. We want to detect these two cars. And after that, all you need is just predict the video. You can, by default, you're going to use the prompt that we used earlier, but if you want to use other prompts, you can also provide other prompts. So I'm going to run this one. This is going to take a little bit longer because it has 177 frames. So it's much more, and it's going to take some time. But after that, you should be able to see all the prompts. For example, after you do the segmentation, all the results are saved in the memory. So if you want to save that explicitly to the computer, then you can use this one, either use the save video segments just to save the binary object, or you can have the object detection overlay on top of the original imagery, and then you can output the video, and you can also set a frame rate. So this one, we are setting the same one is we use above because it's the FPS is 25, right? So when you load the video, you can see the information above here. So this is the original information 25, and it's gonna take I think 2 minutes, 2 to 3 minutes to finish all the segmentation. But if you have a better GPU, it should be much faster. So, and I'm just going to show to save time. I'm just going to show you the result here. So for the cast, you will see here, this is what is being outputted. So this is the outcome of the detection. So it's going to basically over the, oh, it's not finished. Yeah, it's still running. But you can see, right, we have two objects and it's displayed in two different colors. And then you can just use your mouse to skip through to the next frame one by one. It's pretty good, right? So after the final step is basically to combine all the videos, all the images as a single video. So this would be the final outcome, what it looks like. A little bit slow, but it should work, right? So you can see two objects is moving objects. It can detect, and it's really, really nice, really good. You can apply to remote sensing imagery. For example, you might have a car driving, or you might have delivery, whatever. You can check the object pretty nicely. So try it out. Again, I'm going to give you like a summary. So you can initialize the video, and then specify the prompt. You can click the labels, and then just use predict video. And the last step is to save the result. That's it. And if you want to input output as geospatial data, then your input need to be geospatial data. So your input need to be GeoTIFF. It cannot be video. If you provide a video, then the output will be non-geospatial, non-georeference. So pointing to the folder or pointing to a MP4, and the MP4 can be from the internet or can be from a local file. If it's GeoTIFF, you better have pointing to a folder and make sure that they're all the same size. I might improve the package to accept like different size, but for now, just to make it simple, it need to be the same size. And after that, you should be able to segment anything from time series images. Very, very cool. Okay, so that's all for this video. I hope you find it useful. And again, you can try out the other tools, automatic and also predictor. I may create another 2 videos when I have time. That's all. Thank you. Take care. Bye bye.